just get to it in 30 minutes. So what is machine learning? It's an idea. Yeah, you can read, right? Yeah, so it's basically telling a computer to do something without actually telling it exactly how to do it. So let me give you an example. So imagine you're trying to make coffee. You're having a machine make coffee for you. So in a non-machine learning approach, in an imperative approach, we'll tell the bot to get a cup, put in some coffee, whatever, and then hot water, stir it, and you're done, right? That's coffee. Maybe, I don't drink coffee. But that's how you do it if you want to program it explicitly, right? But in a machine learning approach, again, you tell a computer to do something without actually explicitly telling it how to do that. So you just tell the bot, make coffee, and it will make the coffee. But then, how does it actually know how to make the coffee? One example is that you can make the bot watch someone make coffee, right? And then it will try to learn how to make coffee from that. That's basically machine learning. So yeah, that sounds cool. But how do you actually? What's the point of machine learning? So here are some practical applications. Okay, number one, we have facial recognition. So that's basic, just recognize faces. You show a machine. The previous, the older implementations of this is like you get particular points in the face, and then use that instead to figure out which person these set of points are, right? So that's the previous approach. Now, with machine learning, what we can do is just give this picture of a person and tell the machine that this picture of a person corresponds to this particular person, to the identity of this person, or his name, or whatever ID. And then we'll try to learn that this data, the face in the image, is that person, right? So, yeah, there we go. Then, no, sorry. Yeah. There we go. Then medical diagnosis. So last year, in the previous year's Tensorflow Summit, Google revealed that they were able to create a machine, an application that they plug into a computer, and then they scan the retina of a person, and it tries to figure out whether that person has diabetic retinopathy. Now, what's the point of this? What's the advantage of this in India? They don't have a lot of experts with regards to ophthalmology. Is that right? Ophthalmology? Yeah. So, they don't have a lot of experts. So, the problem is people line up for long lines for days in a clinic to try and see if they have the disorder. But the problem is not all of the experts are available, and there's a huge lack of experts. Therefore, this kind of application is able to help even non-experts, doctors who are not experts in ophthalmology, to actually diagnose if you have diabetic retinopathy. So it's basically blindness when you have diabetes. That's the diabetic retinopathy. And this year in Tensorflow Summit 2018, they revealed that they exceeded the accuracy of actual experts with regards to diagnosing this kind of disorder. So this is one of the most powerful applications of machine learning right now. Next is godlike game AI, right? So was it last year or this year? Like Tendy got his ass handed over him by an AI, right? And OpenAI is already planning on a 5-on-5 version of that. We're all screwed now. But yeah, this is one of the applications of machine learning. You can make a really smart agent play against itself, and then it gets better and better, and then it just experts just get their asses handed over them. person is sick or not. So classification. And then we have regression, which is a fancy way for predicting, a fancy name for trying to predict a certain value, a particular value. For example, if you want to try and predict your possible salary, given the company, the performance of your interview, and community involvement, etc., etc. So that's a regression problem. Next is clustering. Like, for example, you want to group movies together without actually telling the computer how to group them. So just give, okay, here are some movies, here are some information about movies, then try to figure out the groupings, how close these movies are together with respect to their own groups, right? So that's clustering. And the recommendation, we're all familiar with this, you know, Lazada, Amazon, or whatnot. Friends you might know, right? In Facebook, that's recommendation. So that's another machine learning problem that can be solved by machine learning. Okay, the types of machine learning. So there are generally three types. Number one is the supervised. This is where we have a computer learn, a machine learn from examples. That's why it's supervised. You're actually giving it examples. So it tries to learn from those examples and then tries to get its accuracy up. That is supervised machine learning. Next is unsupervised machine learning. The example earlier about movies, grouping movies, is an unsupervised learning approach. So basically you give, because in supervised learning you just you give a data. This image is this person, and this image is another person. In unsupervised learning you don't give any of those hints. You just give the data and it tries to learn from that, even if you did not give it any kind of example. An example is, yung kanina. So usually this is the clustering, right? And then we have semi-supervised, wherein you give it some hints, but you don't actually tell it that what it should be. You don't actually have a particular goal in mind. You just want to do something, but you don't have an exact thing in mind. An example of this is yung Dota ball. So you just want it to have a lot of wins, but you don't need to specify what the actual steps they need to be. Right? So that's semi-supervised. Okay, so I didn't really know what to call this, but it's kind of a lineage. So machine learning is there, if you can find it, it's probably there. And so at the very bottom, there's data science. So basically when you're dealing with machine learning, you're dealing with data. You feed it data, which is basically anything that exists, you know. That's data, you just feed it something. So it's data science. It's also you're dealing with data, you're dealing with data science. And then inside data science, we have artificial intelligence, which tries to simulate human affect, behavior, and cognition, the ABCs of human psyche. So it tries to simulate that. That's artificial intelligence. And in that is machine learning. Okay, so what makes artificial intelligence different from machine learning? Now, machine learning is, it tries to learn without being explicitly programmed, right? Because in artificial intelligence, you can actually explicitly program that, right? Like the very first versions, like, not sure about the name, like Eliza. It's a bot that talks to you like, how are you today? I'm fine. How are you today? Yeah, so it's a very robotic response, which was one of the very early chatbots. So it's like SimSimi. It's not that smart, but yeah, you can explicitly program that. So like you can just randomize a response from the database. Yeah, that's explicit programming, and that is not machine learning. So like also an example is the earlier approaches to chess, right? You can just program a minimax and just think what are the possible, the best moves from this particular point. So that's explicitly programming, and that is not machine learning. That can be AI, but that is not machine learning. And next, the subset, which is deep learning. It's called deep learning, but it's a recently coined term. It was previously called ANNs, artificial neural networks, but when a lot of layers were added, they just call it deep because it's deep. So that's why they call it deep learning. So when you hear deep learning, it's just artificial neural networks. No. There we go. So this is what, just for reference, this is what artificial neural networks look like. So you have input, and you have hidden layers, and then you have, the output layer. So most of the time, if you're building business applications, you don't really have to think about this. Applications like libraries like Tensorflow and the other libraries can all build this without you even thinking about any computation, unless you are into research. So that's the basic HR and deep learning. There we go. So this is the typical machine learning process. Okay, so listen. First we have to define the problem, because if you don't define the problem, you won't have a goal. So, it'll suck. Then next, we have gathering data. We have to gather data. So there's a lot of things happening in here, and they say that one of the most important steps for anything actually, for 90% of the job of building a machine learning model is gathering data and processing the data, which is also the same for cybersecurity, where 90% is reconnaissance. Anyway, and then you get the data. So for example, we have an image, right? What kind, that is now data. So you can collect images. So then after that, you have to convert the data to something that a machine can read. So an example of that would be converting the image into an array of pixels, or a 2x2 array of pixels, or a 2x2x3, which is RGB. You get what I mean. So that's basically it. So that's gathering data. Then what's the most important thing? Because if you don't know what representation of data you have to input into your algorithm, then that wouldn't work. Just inputting an image there without pre-processing it is just gonna break you, right? It's just gonna make your model fail. But if you know how to process your data properly, or know what tools you need, then you're off to a good start. Then after that, we train our model. This is the part where we feed the data into our algorithm, whichever algorithm we need. It depends also on the approach, if it's supervised or unsupervised, and what kind of problem, if it's classification, regression, or whatnot, right? Then we go. So then we evaluate the model. So we actually check if the model that we train is actually doing its job. For example, if we build the model that tries to recognize faces, and it's unable to recognize faces, then there's something wrong. So that's the evaluation part. You try to evaluate the model and see if it actually does the job. So for example, you have trained a model, you have made a model learn, and you have seen that it only does 5 correct answers out of 10 when you feed it images. So when you feed this image, it predicts it as another person, and it does that 5 times out of 10. Then that's bad, because that's 50% accuracy, which is pretty low. You can't use that in an application, right? You can't use that in an application. So you have to evaluate the model. Then you test the model. So what we usually do in machine learning is, if you just, for example, if you give images to a particular machine and have it learn, and if mo ulit yung same image, alam niya yung image na yun, right? Alam niya kung sino yun, right? Same images pa rin yung feed mo. So what we do to test is, we take a different picture of the same person that was not given to the machine. Right? So, kung makita niya itong different image, then alam natin na nag-learn yung machine, right? Kasi hindi pa niya yun nakita before, right? Ayun. So then, after testing that, we continually improve the model. So something's wrong. Maybe kulang tayo ng data. Or may something wrong sa algorithm natin, then we change it. So then we improve the model. And then we deploy the model. So to the cloud or whatever, then we can start using the model. Then people can now start using your machine learning model. When we refer to model, yun yung machine na nag-learn or mag-learn. So it's called a model because it's a mathematical model, but you don't really need to think about it much. There we go. So here are some machine learning tools, right? So wait, hindi pala. Ayun. So meron tayong scikit-learn, Keras, Tensorflow, PyTorch, R, and Julia. So scikit-learn, these tools are mostly Python, except for the languages here. So scikit-learn, back before TensorFlow was invented, this was the premier library for machine learning. So most of the things that you need are here. If it's basic classification, the basic regression, it's there, right? You can use it. So scikit-learn is pretty easy to use. Next is Tensorflow, which is Google's premier machine learning library. It's actually a deep learning library because you're building artificial neural networks with Tensorflow. Especially with the first version, you actually have to build the network one by one, tensor by tensor, node by node. And then we have PyTorch, which is for Facebooks. And then we have R, which is a language for statistics. Because they say that machine learning is just glorified statistics, when you think about it. And then Keras is a more abstract library. This is actually what I recommend for beginners. If di mo pa talaga alam gumawa ng neural network, and you absolutely have to use it. Especially for like facial recognition, we usually use deep neural networks because CNNs. Hard to explain that. But yeah, this it makes it easier. So, but if you know what you need to use, you just drop it in. It's that easy. But it's just an abstraction. Underneath, you can choose to use TensorFlow as the one that actually does the calculation, or PyTorch or whatever. Usually, I think the default for this is TensorFlow. So when you install Keras, you use TensorFlow. So I recommend this if you're just beginning. If it's not really that groundbreaking, you can just use Keras. If you're doing research, use TensorFlow. That's basically the dynamic. And then I forgot Julia. Julia is a new language which allows you to have the ease of use of Python, then the statistical API of R, and then the speed of C. So what are you looking for? There's nothing else to look for. It's really fast, really easy to use, and it has the data frames available in R. But the problem is, it's not nobody knows it yet. Sino ba may alam Julia dito? Okay. So bakit gumawa ko ng Julia community dito sa Philippines? Anyway, ayun. So code examples. Let's get right to it. So I'll have to open this up. Oh, wait. I have to open it up. Okay. No, I don't. Copy. Paste. There we go. So we'll try to do this. I'm not sure if this will load. Okay, so here is a TensorFlow example. So we're dropping you off to. So the basic if you're using plain TensorFlow, it's hard. You're actually building a neural network-ish. So you're building it from you're building nodes and connections. So let's look at this. So there's the code. So we're importing here, are you seeing this? Yeah. So here we're importing TensorFlow, just import TensorFlow, then importing NumPy, then the plotting library. There we go. And then we set the parameters. We don't have time for this. But this is basically the settings that you change. So if you want to improve a neural network. So learning rate is one of the most important ones because this is how much you want the neural network to improve. So because sometimes if you make it too high, it converges. How do I explain that? Sorry. It converges. So it doesn't learn anymore. Right? It thinks it has learned, but it actually doesn't learn. Sorry, I can't convert that into another term. So there we go. So meron tayong data dito. So we have training X and training Y. So these are our this is our training set. So we have a set of numbers. Yung problem natin dito is we'll try to figure out the next number, right? Given the corresponding number given a set of numbers. Actually, it's not. But yeah, if you take a look at this, we're defining variables, right? X, Y, W. These are basically the weights of the network, the loads of the network. That's not. This is difficult. So, but this is basically how you run a TensorFlow application. So you have gradient descent optimizer. This is how you make your network improve, and then you create a session. And then you run it, and mag-loop ka over, you sasabihin mo kung ilang iterations para mag-learn yung machine mo. And then after that, ayun na. So ito na yung result natin, optimize siya. So this is linear regression, right? When you say linear regression, we're trying to fit a line in our data. So in here, ito yung data natin, right? Ito yung data natin. So it tries to, so for example, given a number of 3, it tries to predict na ito siya. So it tries to pick a line that best fits your data. So for example, ano ba yung wala dito? Hindi nag-exist na number. So walang 5. So kung may 5 po. So yung 5 natin, since wala, itatry niya, sasabihin niya, ito yung value. Kung ano yung value dun sa line, that's linear regression. So that's one of the most basic na machine learning algorithms, machine learning problems. There we go. So that was hard. So let's take a look at something simpler. So let's try Keras. Again, Keras uses the TensorFlow underneath it, but it has a much simpler API. Oh, nga pala. If you want to try machine learning experiments, you should try Collaboratory. Google's Collaboratory. So meron siyang free GPU if you want to try it out. So usually. So web developers, which is I think ito yung tinitrain sa atin, right? We are being trained to be web developers because it's the most lucrative. Trade, because everybody does. If you're a business, you do web. If you're a business, you create websites, you inform people what you do. So that's what we do, web developing. So what language is being used in web development? And that is JavaScript. If you want to do back-end, front-end, mobile, IoT, Gen 5, JavaScript, right? So you can do anything with JavaScript. But the problem is, even if JavaScript is everywhere, there is no standard library for machine learning in JavaScript. So that makes us feel sad, right? Okay? Even if we know JavaScript, sino din marunong ng JavaScript? Oh, mas marami. Mas marami yung mas marunong ng JavaScript. So what happened was, even if we have a bunch of deep learning libraries in JavaScript, walang masyadong supported with the community, right? Until Google made deeplearn.js. Okay, so this was released a few years ago, I think 2 years ago, and a lot of people use this. na ikaw talaga nagpa-plot, ikaw nag-create ng computational graph mo. So that was a problem. Not a lot of people could use it. So it still felt like climbing a really tall mountain because it wasn't really difficult. So a better answer was revealed to us this year by the Tensorflow team, and that was Tensorflow.js. So what happened was, before, meron tayong yung TensorFlow na yung low-level API, so nodes talaga. With TensorFlow.js, we have the ability to actually add just layers. Like with Keras, the model that adds something, model that adds a layer. So you just add layers, right? So you don't have to think about what those, how they're actually connected. You just add them up. That's one of the most powerful features of TensorFlow.js. And that you can create models and plug it into your browser and they will just work. Train them and then plug it in and then use them. So ito yun, so maliit siya. So meron siyang layers API yun yung sinabi ko. And you can actually build models in the browser. So yun, so meron akong sample. Let's try if this will run. Kasi last time I tried this, my computer froze. So repo, hindi, save pala. Come on. Copy. Paste. There we go. So yun. So problem here is, marami pang issues with TensorFlow.js, but it works. It actually still works. So one of the problems is when you're training, it freezes the browser. But you know, why would you train in the browser? But this is here for just to show you that it actually does train. So let's open it up. Tingnan natin dito sa console kasi dito lumalabas yun. So let's click train. Matagal siya. Ayun, Firefox. Wala ang Firefox. Ayun. Titrain na siya. So yun, nakikita niyo ba? Sa baba. So that's, ayun. So, ito, don't mind this. That's basically one accuracy. This is 100% accuracy, which never happens in the real world. So, yun, nag-99% tayo, tapos na-training, tapos accuracy natin is 1. Huwag kayong maniwala, hindi yung totoo. Pero, usually, it is being rounded off to 1, so it's actually basically 0.99 something. So, it's pretty high. So, ano yung actually yung ginagawa nito? So, here, training complete. Yay! So, actually, yung ginagawa nito, behind the scenes, is we have 4 ballots, like fake ballots. I just photoshopped them. And then, I trained this model to figure out which candidates are being selected, right? So if this is a multi-classification, multi-label problem. So you can pick many candidates, and it will try to figure out which ones you pick. So let's see. So lalagyan ko ng finding dito. It's a bit contrived, but bear with me. .png. So here's the file name. So I'll try to check if tama. Ayun. So yung filtered verbing for Miriam. Tingnan natin kung tama. So dito, slightly shaded lang yung Duterte. So hindi niya consider. Yung kay Binay na medyo off a bit. Tapos yung kay Miriam, super shaded talaga sa. Right? So you try to figure out really which one I voted. So in this case, kahit na may shade yung iba. So let's try kung maalala ko yung iba file names. 01 0, tama ba? Wala, hindi yun. Kung malala yung mga file names. Wala na, tingnan natin yung code. Copy. By the way, if you want to take a look at the code, how I actually did it, just visit my repo. It's here. So, tingnan natin yung mga pangalan ng... So, ayun pala. 50001. No, what yan? Yung tayo sa 001. 2. C. Let's try that out. 001. 2. Sorry, this is a bit contrived kasi ito yung training set ko. Check. Yun, voted for B9. Tingnan natin. So, yung maliit lang na shade, tapos maliit na shade. So, it voted for B9 kasi siya yung pinakamalaki. Kahit na hindi actually filled. So, now this is a supervised training problem. Kung sinabi ko na this is actually not valid, it will say, no, I did not actually vote for anyone. But I said that this is valid. So, this actually was considered na vote pa rin. So you can do this in your browser. Lahat ng training sa browser, lahat ng data sa browser, lahat ng information. So you can do something like this. I'm actually planning on doing an actual project for the actual ballot sa voting. Pero baka gusto nyo yung thesis kayo na, right? So do we still have anything? Ayun, may issues with Tensorflow.js, but not sure if this is valid because these concerns were a few months before when kaka-release pa lang ng Tensorflow.js. First of all, ang callbacks. Sorry, we can discuss. Wrong. The descriptive yung errors, sometimes they will make it behind, so you have to search the GitHub repository. And then walang estimators API. Yung estimators API, meron ito yung keras. Basically, you say na gusto ko ng image classification model. Meron ka na. You don't have to add anything. Just bigay mo lang yung data mo. Gusto ko ng LSTM model. Sorry, I can't explain that. Pero, if you want that, you just get it. You don't need to add any layers anymore. It will just work. So, that's an estimators API. But lately, mayroong nag-release ng bagong library. They call it ML5.js, which wraps Tensorflow.js. So, tingnan natin ito. Let's search for ML5. ML5.js. Let's try this out. Just check it out. So, reference. Let's see. No, wag yan. Hindi tayo sa Santos data. Ay, ito. So yun. So, for example, gusto ko ng image classifier. Gagamitin ko lang yan. I just pick that function, image classifier. And if I feed it something, it tries to recognize what object that is. And you can actually retrain this. So if you want to do facial recognition, you can just retrain this function. Right? So let's see what this looks like. So yun, image classifier mobile net, it's a type of mobile app, it's a type of neural network. So yun. And then, ilalagay mo lang yung image, yung document element by edu. Kumukuha lang siya ng image element, and nilalagay niya dito sa function. And then it tries to predict what that is. Ilang lines of code yan? 1, 2, 3, 4, 5, 6, 7. 7 lines of code. You have an image classifier. Boom. Easy, right? So, meron tayong example nito. So, examples. Okay. So yun, basically, just import the library and just use whatever they have. Although incomplete pa yung documentation lang, it is pretty good.